Hello girls, I hope you're staying safe at home. To continue with the atomic structure and chemical bonding, today we are going to talk about covalent, also known as molecular bond. So to define a covalent bond, it is a bond that is formed between two combining atoms by mutual sharing of one or more pairs of electrons. And the compound which is formed due to the sharing of one or more pairs of electrons is known as a covalent compound. So in the last upload, I told you about electrovalent compound, which is formed by the transfer of electrons when two atoms came together by forming a bond between them, which was known as electrovalent bond, and that bond was formed by transfer of electrons. But covalent bond means it is a bond formed between two atoms by sharing of one or more pairs of electrons, and the molecule which is formed due to the sharing of electrons is known as a covalent molecule. Like for example, you can take hydrogen, has one electron in its outermost orbit. It will share that one electron with another hydrogen. So now this hydrogen has duplet configuration, and this hydrogen also has duplet configuration, and it will form one molecule of hydrogen. So hydrogen is a covalent molecule. Now you know the atoms of non-metals have 5, 6 or 7 electrons in their outermost shell, except, remember, very important, carbon, which has 4, and hydrogen, which just has 1 electron in the outermost shell. So this type of elements, they do not favor the loss of its electrons due to certain energy considerations, because they will be losing their orbit, outermost orbit, and like there will be some disparity in the energy. So transfer of electrons is not possible. So the only thing these atoms can do to complete their octet is by sharing. Mutually sharing means like both must benefit by sharing of one or more pairs of electrons. Now each atom, remember children, contributes equal number of electrons. So whenever a non-metal combines with another non-metal to attain a stable configuration. So when they are sharing, actually they are trying to attain either duplet configuration or octet configuration. So they want to become stable. So in this case, they share the electrons between the atoms and a covalent bond is formed. Now I already explained to you how hydrogen forms a covalent molecule. In a similar way, hydrogen chloride will form a covalent molecule by sharing electrons. So let's take a quick look how hydrogen has 1 electron in its outermost orbit, and chlorine has 7. 1, 2, 3, 4, 5, 6, 7. So hydrogen will share 1 electron, chlorine gives it, okay, and chlorine will share 1 electron from hydrogen. So hydrogen has attained duplet configuration and chlorine has attained octet configuration. Okay, so there are 3 types of covalent bonds. One is known as a single covalent bond, next is double covalent bond, and then next is triple covalent bond. So a single covalent bond is formed by sharing 1 pair of electrons between atom, and each atom gives 1 electron. So that is known as covalent bond. Okay, so let's take a look here. See, so here when we talk about a single covalent bond, we put a short line between two atoms. So hydrogen, 1 electron they were sharing. So hydrogen here 1, here. So there is a short line between them. So similarly, chlorine has 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 1 it shares. Here 1, here 1, here it will share. So this chlorine will have 8. This chlorine will also have 8 electrons in its outermost orbit. So it has a single covalent bond between them. Hydrogen chloride, 1 here, 1, 2, 3, 4, 5, 6, 7. So it is sharing here in between, single covalent bond. Similarly, ammonia, NH3, nitrogen has 1, 2, 3, 4, 5 electrons in its outermost orbit, and you know hydrogen has 1, 1, 1. So it forms a single covalent bond. And methane is CH4. Carbon has 1, 2, 3, 4 electrons in its outermost orbit, and hydrogen has 1, 1, 1, 1. So they share a single covalent bond between each. And same way, water also, oxygen has 1, 2, 3, 4, 5, 6 electrons in its outermost orbit. Hydrogen has 1, 1. So hydrogen shares 1. Hydrogen shares 1. So hydrogen will have duplet configuration and oxygen will have 8 electrons, counting 1, 1 shared from hydrogen. Carbon tetrachloride CCl4. Carbon has 1, 2, 3, 4 electrons in its outermost orbit. Chlorine has 1, 2, 3, 4, 5, 6, 7. So 1, 1 it will share out of the 7. So carbon will have altogether 8 electrons, 1, 1, 1 shared by chlorine, and chlorine will have 8 electrons altogether by sharing 1 on either sides. So all these you can see are denoted by a single line to show a single covalent bond. So in the same way, a double covalent bond is formed by sharing of 2 pairs of electrons between 2 atoms. So a double bond is actually a combination of 2 single bonds. So it is represented by putting 2 short lines like equal to sign between 2 atoms. For example, how is oxygen formed? Let's take a quick look again. Oxygen has 1, 2, 3, 4, 5, 6. Another oxygen atom, 1, 2, 3, 4, 5, 6 electrons. So there, this 2 is shared. Okay, so double covalent bond. This oxygen has 8 electrons now, and this oxygen also has 8 electrons. So oxygen molecule is formed. Okay, so similarly, a triple covalent bond is a combination of 3 single bonds. Now let's see the formation of a triple covalent bond. Nitrogen has 1, 2, 3, 4, 5 electrons in its outermost orbit. Nitrogen has 1, 2, 3, 4, 5 electrons in its outermost orbit, and there 1, 2, 3 pair of electrons are shared. So this nitrogen has 3, 3, 6, 7, 8 electrons, and this nitrogen also has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So it forms the nitrogen gas and a triple covalent bond. So single covalent bond between chlorine also you will see. Chlorine has 1, 2, 3, 4, 5, 6, 7 electrons in its outermost orbit. Another chlorine atom, same thing, has 7 electrons in its outermost orbit, so it shares 1 electron. So this chlorine has 8 electrons now, octet configuration, and this chlorine also has 8 electrons now. So there we have, by a single dash, a single covalent bond. Okay, then we have oxygen, double covalent bond, and then we have nitrogen, triple covalent bond. That means what is this actually showing you? The pairs, 1 pair shared, 2 pairs shared, and 3 pairs of electrons shared. Okay, so we have a single covalent bond, a double covalent bond, and a triple covalent bond. And sometimes you'll see molecules, they have a combination of single as well as a double bond. Ethene is an organic compound with the formula C2H4. So here you can see how carbon has 1, 2, 3, 4 electrons in its outermost orbit. 4, 5, 6, 7, 8. And hydrogen has duplet. So same thing for this carbon. 1, 2, 3, 4, 5, 6, 7, 8. So this is a combination of a single as well as a double bond, and in some cases you will also see double or a triple bond also. So here you can see ethine, another organic compound with the formula C2H2. Okay, so you can see how there is a single bond between this hydrogen and carbon, single bond, and between carbon there is a triple bond. You'll be learning more about this in the part 2 of this book when we do organic chemistry. Now next we move on to covalency. Covalency of an atom is the number of electrons that takes part in the formation of shared pairs. That is, covalency of hydrogen is 1 because it is sharing 1 electrons each, oxygen 2, they are sharing 2 each, nitrogen 3, and carbon 4. Now next we move on to non-polar and polar covalent compounds. Now covalent compounds are non-polar when the shared pairs of electrons are equally distributed between the two atoms. There is no charge separation and the molecule is symmetrical and electrically neutral. Now for example, chlorine, hydrogen, oxygen, they are sharing equal number. They have hydrogen has 1 electron in its outermost orbit, so it is sharing 1. Chlorine has 7, so it is equal. Oxygen has 6, so it is equal. So these covalently bonded atoms are identical. The shared pairs are at equal distance from the combining atoms, and the shared pair of electrons is equally attracted by the nuclei of these two type of charge, because in the nucleus protons are there and electrons are attracted by the protons, isn't it? Now supposing the covalent compounds do not have equal number of shared electrons, they are said to be polar. And remember that when they are polar, the shared pair of electrons are not at equal distance between the two atoms. So as a result, there will be a fractional positive and negative charge on them, and they ionize in water. Okay, for example, hydrogen chloride. Let's take a look here again. So here you can see chlorine has 7 electrons and hydrogen has only 1 electron in its outermost orbit. So that means when we take a look at hydrogen, hydrogen has 1 electron and 1 proton. Okay, and chlorine has, the electronic configuration is 287. So total it has 17 electrons, which is equal to 17 protons. So when we compare the negative charge here and the positive charge here, which one is more? Naturally, chlorine is more. So as a result, this electron of hydrogen will be pulled towards, this electron will be pulled towards chlorine more because it has 17 positive charge. So as a result, it develops a very small positive charge which is known as delta positive, and chlorine develops a very small negative charge which is known as delta negative. Okay, so what happens, this type of compound, it will ionize in water. So if we put HCl in water, it will turn into ions, H plus and Cl minus. They ionize in water. So basically, remember children, polar covalent compounds, they ionize in water. So covalent bond is formed when both the combining atoms have 4 or more electrons in the outermost shells. Okay, exceptions: helium, beryllium and boron. Hydrogen can combine with all non-metals with the help of covalent bond, because hydrogen is the only non-metal which has a positive charge. Okay, so now your assignment for this week is to draw all these structures that I am going to explain to you right now. Now there are many structures of covalent molecules that we are going to learn. So please take your time and you can submit this assignment by Friday. Okay, so first is hydrogen molecule. So here you can see hydrogen has 1 electron in its outermost orbit. Another hydrogen atom has 1 electron in its outermost orbit. So there you can see that these two are shared between them. So this is how you're going to draw. Now to draw the electron dot structure, you'll write down hydrogen and write down 1, show, and after combination you can draw with the help of overlapping circles. So here you can see this is the overlapped portion here, hydrogen, 1, 2 in the middle, hydrogen, and you draw a circle to show that this hydrogen has 2 electrons and this hydrogen also has 2 electrons. So it has duplet configuration. So here you'll see one shared pair of electrons, a single covalent bond, leading to the formation of hydrogen gas. Now chlorine. You know chlorine has 1, 2, 3, 4, 5, 6, 7 electrons. So 1 electron is shared between 2 chlorine atoms. So you can see this chlorine now has 1, 2, 3, 4, 5, 6, 7 plus this shared pair, 8. Similarly, this chlorine atom also has 8 electrons in its outermost orbit, and electron dot, as usual, you will see one shared pair of electrons, a single covalent bond leading to the formation of a chlorine molecule, because a chlorine molecule is made up of 2 atoms of chlorine. Now oxygen molecule. Oxygen has 1, 2, 3, 4, 5, 6 electrons in its outermost orbit. 1, 2, 3, 4, 5, 6. So they are sharing 1, 1, 2 electrons each. So in this way you'll see that this oxygen atom now has 1, 2, 3, 4, 5, 6, 7, 8 electrons altogether. So similarly this oxygen will also have 8 electrons. So here you can see the electron dot. You'll write oxygen and 6 electrons you'll draw around it, 3, 4, 5, 6, and there you'll show in the middle 2 pairs are shared and a double covalent bond which results in the formation of oxygen molecule. Now nitrogen has 1, 2, 3, 4, 5, okay, and then 3 pairs are shared. So this 3 here, 1, 2, 3, 4, 5, 6, 7, 8. So octet configuration. So electron dot you will draw in this manner. You'll write down nitrogen in the center. You'll show how many are shared. Total 3 pairs are shared, and then you'll see the triple covalent bond resulting in the formation of the nitrogen molecule. Now hydrogen chloride. Hydrogen has 1 electron in its outermost orbit, okay, and chlorine has 7 electrons. 1, 2, 3, 4, 5, 6, 7 electrons in its outermost orbit. So this 1 electron of hydrogen is shared with 1 electron of chlorine. So 7, chlorine is getting 7 here plus 1, 8, and hydrogen is getting 1 here, 1 here, 2. So hydrogen is duplet and chlorine becomes octet. So your electron dot, there you'll see this X sign is the electron of hydrogen, 1 electron, and these dots are the electrons of chlorine. So a single covalent bond is formed. Now water. Hydrogen you know has 1 electron. Hydrogen 1, because the formula of water is H2O. How many atoms of hydrogen? 2. 1 here, 1 here. Oxygen in the middle. Oxygen has 1, 2, 3, 4, 5, 6 electrons. So 1 is shared with hydrogen here and another with another hydrogen here. So oxygen has total now 1, 2, 3, 4, 5, 6, 7, 8 electrons. And hydrogen as usual forms duplet configuration. So to show the electron dot structure, there you'll write hydrogen and draw 1 electron. Oxygen you'll draw 1, 2, 3, 4, 5, 6. So you will show how oxygen has 8, and then this one hydrogen has 2 here. Okay, and 2 single covalent bond leads to the formation of water, that is H2O. Now next we move on to the formation of ammonia. Formula of ammonia is NH3. So how many hydrogen atoms do we require? 3. 1, 2, 3. By now you know hydrogen has only 1 electron in its outermost orbit, which it shares with 3 electrons. Okay, not 3. Each hydrogen will share 1 from nitrogen. Now here let me show you. This is nitrogen, this is nitrogen, this is nitrogen, this is nitrogen. Okay, so here you will see hydrogen duplet has 2 electrons, this also has 2 electrons, this also has 2 electrons, and all together you will see that nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. These electrons which is found on the outermost orbit of nitrogen, which is not shared with anything, are known as lone pair of electrons. Okay, please keep this in mind. We'll be talking about it later on. So this is your electron dot here. Hydrogen you'll show with X, nitrogen with dots, and after combination you will see 3 covalent bond, and please do not forget to show the lone pair of electrons. Okay, next is carbon tetrachloride. Formula of carbon tetrachloride is CCl4. Tetra means 4, chloride means chlorine. So there are 1, 2, 3, 4 chlorine atoms. Carbon you know has 1, 2, 3, 4 electrons in its outermost orbit, and chlorine has 7. 1, 2, 3, 4, 5, 6, 7. So 1 is shared with carbon on either side. There are 4 chlorine. Okay, so each chlorine, it had 7, so it is sharing 1 from carbon. So now each chlorine you will see will have 8 electrons, octet configuration. And similarly carbon also had 4, and when it is sharing 1, 1 with 4 chlorine atoms, 4 plus 4 will give 8. So it becomes octet configuration, it is stable. So this is the electron dot diagram that you are going to draw. Okay, so finally you'll see this is after combination. Carbon has 8, chlorine has 8 on all sides, and there are 4 single covalent bonds leading to the formation of carbon tetrachloride. Next we come to methane. You know the formula of methane is CH4. Carbon has 4 electrons, 1, 2, 3, 4 electrons in its outermost orbit. Okay, and you know that hydrogen has 1, 1, 1, 1. So when on each side with one carbon, with one hydrogen atom, and carbon shares 1, this hydrogen becomes duplet. So same way this hydrogen also becomes duplet, this hydrogen becomes duplet, this hydrogen becomes duplet, and overall carbon will have 8 electrons. It will become octet. Okay, so electron dot, it is shown how it is shared on either 4 sides, and after combination it turns into this, or you can write it as 4 single covalent bonds. Okay, so that is how methane molecule is formed. So you are going to draw these diagram. You will draw the orbit structure as well as electron dot diagram. So remember children, covalent compounds are made up of molecules with very weak force of attraction because they are sharing. So they are always gases, liquids or soft solids. These compounds are volatile. These are the properties of covalent compounds. Okay, these compounds are volatile. Volatile means they can easily evaporate, they can turn into vapor, they have a low boiling as well as low melting points, they are non-conductors of electricity in solid, molten, aqueous state because they do not have free ions. Because you know, to conduct electricity they must have ions, so that the ions will carry the electric current. So on passing electric current, non-polar covalent compounds do not ionize. If you remember, it is only the polar covalent compounds which ionize in water. So only some of the covalent compounds are polar in nature, so they form ions, so they ionize in their solutions and they act as electrolytes. Electrolytes are chemical compounds which conduct electricity in the molten or liquid state, aqueous state. When they are in liquid state, that is when they turn into ions. And remember, these compounds are insoluble in water, but they dissolve in organic solvents. Organic solvents are solvents or liquids which are found in the lab. They are of course chemical compounds. Okay, so with this, children, we come to the end of this chapter. Till then, children, till we meet again, stay safe. God bless you.